Okay. So, dear students, in previous session we discussed about introduction to association analysis and what is the use of creating association rules and what are the metrics which are going to be used in order to form association rules like support and confidence we discussed in detail. Now, in continuation with the previous concepts, today we are going to see the a priori concepts and what is the use of a priori algorithm in association analysis. Let's have a look on this basic definition of a priori algorithm. So in this a priori algorithm, when we are having large item sets, when we are having more number of items in our transaction history, when these items are going to be participated in forming item sets, when the number of items or item sets which are in larger scale, then we can go for a priori algorithm. That means when we are getting more number of item sets, these item sets are going to be generated and pruned and eliminated. Finally, the best larger item sets are going to be selected. So in this whole process, when we are having a large amount of data, a priori algorithm will give better results. Now what is contrapositive related to a priori? If an item set is not large, none of its supersets are large. If an item set is not large, none of its supersets are not large. That means, let us take one small example here. Here we are having an item set called ABC. If the item set ABC was not repeated more number of times, then we can't expect a superset which is going to be formed with ABC. Like it can be ABCD or it can be another ABCE or anything. If an item set is not a large item set, then all the supersets which are going to be formed with these item set are also not large. Now look at here. So in this construction of item sets using a priori algorithm, we will take the help of lattice architecture or lattice structure. Here we started by considering the null value or you can say empty set. Initially only and zero elements or zeroth element or you can say null element is going to be taken into consideration. And here in this example we have taken 4 items. The items are A, B, C and D. Let us assume these are the 4 items which are available in a supermarket. A is a product, B is a product. Like that we are having only 4 products have been taken for consideration. Using these 4 products, we want to form combination of 2 items and 3 items and we can go up to n number of items. So here when we want to take the combination of items like A with remaining all items, like we will get AB, AC and AD. Like we'll create all combinations with B, BC, BD. Already A and B is already taken, so we are not taking into BA again. Next, C and D combination is CD. So initially we are having 4 items, that is A, B, C, D. Using these 4 items, we want to form item sets. So generally, when we are having n number of elements, we will get n to the power 2 to the power of n minus 1 item sets. 2 to the power of n minus 1. Here we are having 4 items, we will have 2 power 4 minus 1, that is 16 minus 1, we will have 15 item sets like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. And remaining one is null item. So the formula is 2 to the power of n minus 1, where n is the number of elements which are participating in the construction of item sets. So here what we have created here, using these 4 items like A, B, C, D, this is a set or you can say initial item set. Using these 4 items, we started creating one item sets like A, B, C and D. And next we are creating 2 item sets, AB, AC, AD BC, BD and CD. And we are creating 3 item sets, ABC, ABD and BCD, and finally 4 item sets. So all these item sets we can observe in this lattice architecture. So using 4 items in a given item set, we started creating a power set, or you can say subsets, which is 2 to the power of n minus 1, where n is the number of elements. So 2 power 4, 16 minus 1, 15. So totally we got 15 item sets. So this is the initial process in a priori algorithm creating a item sets. So here we started deriving all 15 item sets with a combination. Among these item sets which are best useful for analytical activity, those are going to be selected and remaining are going to be neglected or eliminated from the analysis. That we are going to see in coming slides. So this is the way of deriving item sets from a given set of elements. Now in our previous example, in our market basket analysis, we have taken some of the elements like bread, jelly, milk and peanut butter. We started creating all larger item sets here. Here, the items which are participated are bread, jelly, milk, peanut butter and beer. From these are the large items. That means most number of times which are repeated, or you can say most of the customers purchased. So among these 5, these 4 are the larger items which are repeated. That means jelly was not repeated here. So let us assume jelly is not up to the mark. We are not considering into analytical activity. And these are the 2 item sets here, like beer, bread, beer milk, bread milk, milk peanut butter. Like that we got 2 item sets combination. Among these 2 item sets, only this item like bread and peanut butter is most repeated item. Now how can we select among these existing candidates a large item set? For that already we discussed, we have to take a threshold value of support and confidence. So here we took support as 30%, confidence as 50%. That means among all transactions, at least any item set, if it repeats 50% and more than 50%, then only will take it into consideration. Remaining all item sets are going to be neglected or will not be considered in analytical activity. So these 2 formulas we have to remember carefully. Support and confidence, S and alpha. Sometimes we will call it as S and C. Now we will see how this a priori algorithm is going to be executed. So initially, the item sets of size in I, that means number of items which are available in that data set are going to be taken into capital I, where capital I is equals to, let us assume here, number of items. It's like I1, I2, I3 and I4 and so on up to n number of elements. Now here, after assigning all the elements to this C1 attribute, we want to find out the large item sets of size 1. That means we want to find out 1 item sets which are repeated based on the threshold value. Now here the process is going to be repeated. Here I equal to 1, repeat the process, I equal to I plus 1, that is initial step. Now look at here, a priori generation. This function is going to be used here. In this a priori generation, large item sets based on 1 item set. After that, 2 item sets, and we can go up to n item sets. Is going to be repeated. So here we are repeating count Ci to determine Li. Here count, we want to find out the count of each and every item set which was repeated more number of times, and we have to repeat the process until no more large item sets are found. So among the existing transactions, whichever is having larger or more number of times repeated is going to be taken into consideration. Now, how can we apply that function, that is a priori generation? So in a priori generation, generate candidates of size I plus 1. Initially we generated only for one item set. Now we want to repeat the process up to n number of item sets. Create candidates of size I plus 1 from large item sets of I. Initially I equal to 1. Now we are incrementing it by 1. So initially I value is 1. Next we will take 2. Now what is 1 and 2 here? Item sets. Let us say 1 indicates any item which are single item sets. 2 indicates 2 item sets. The combination of 2 item sets like BC, like AE. Like this we have to repeat the process. Now what is the approach we used here? We applied join operation. That means join large item sets of size I if they agree on I minus 1. I minus 1. So may also prune candidates whose value which are not larger. That means let us assume here item set A is repeated 5 times, B is repeated 2 times, C is repeated 3 times. Let us assume we want to take 50% of threshold based on the support count. Only A is going to be selected and B is going to be selected. Sorry, C. B is going to be pruned. That means eliminated from the analysis. So at any stage, whichever is best suitable value or item set is going to be taken into consideration. That is called, we are applying pruning the candidates. Now this is the example of a priori generation based on another data set here. Here we are having totally 20 transactions. Among these 20 transactions, if you observe carefully, there are items are there. Like the first transaction purchased by a customer only blouse. In second transaction, shoes, skirt and t-shirts have been purchased by another customer. Like that we are having totally 20 transactions. In these 20 transactions, some transactions are having only one item set like blouse, jeans, t-shirt, jeans. It is only one item set. Some customers they purchased 2 or 3 or more number of items. Like here they purchased only 2 items like jeans and t-shirt. Here they purchased 3 items. Some customers they purchased here 5 items. So here we can able to clearly observe number of items which have been purchased by each and every customer. Now the number of items indicates here item set. Here it is one item set because only one item is repeated here. That is item set 1. If you look at here, it is 2 item set. So here we'll take all the 2 item sets and we'll observe which is having repeated more number of times. That is the way of selection. Now look at here. After scanning all those 20 transactions in the previous slide, we found there are one item sets are there are 6 one item sets. That means there are 6 unique values in that given transaction. Just we will observe again here. So if you look at carefully, there are 6 unique items only available in this given 20 transactions. Those 6 unique values are blouse, jeans, shoes, shorts, skirt and t-shirt. And after performing second read operation or scan operation, we came to know the following 2 item sets like jeans and shoes is 2 item set was appeared in the data set. This is another 2 item set purchased by customer. Like this, we are able to see nearly 10 2 item sets are there. And if you look at, if you are able to see the 3 item sets, there are 7 3 item sets are available. That means 7 customers have purchased 3 item sets, 10 customers purchased 2 item sets, 6 customers are 6 transactions having only 1 item sets. And here only one transaction we can see only 4 item sets in together. So when we look at all these available candidates, we want to remove some of the item sets. Now after applying the minimum threshold value like 15 confidence and 13 support, one item has been eliminated, that is blouse. Look at carefully here. Jeans, shoes, shorts, skirt, t-shirt have been remaining as it is. Only blouse has been eliminated. Why it has been eliminated? Just have a look at again here. If you look at carefully, it was repeated only one time. If I am not wrong, only one time it is repeated. Sorry, there is one more time. Yeah. If you take the count of individual elements, so the blouse is repeated 3 times. If you compare another one, like have a look on this jeans, how many times it is repeated? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So jeans is repeated 14 times. If you take that number of times it was repeated, here we pruned this item called blouse. Like this, after considering all these 10 item sets, 10 2 item sets, among these 10 2 item sets, some of the items have been eliminated, and finally we got only 7 most repeated or up to the mark based on the threshold value have been taken into consideration. Remaining 3 item sets have been eliminated. And when it comes to 3 item sets, only 4 3 item sets have been qualified based on the minimum threshold value. It can be support or confidence. And only 1 item set was as it is available in 4 item sets. So this is the way of, here what we are doing, we are generating item sets using a priori, and here what we are doing, we are selecting. We are selecting the item sets by applying pruning operation, that is elimination. So this process can be repeated up to size n. Here we stopped only up to 4 item sets and we didn't find any 5 item set in the given transaction, so it has been closed. Let us convert this example into real-time application. When we want to analyze the customer behavior pattern in any shopping mall, the concerned manager of the store want to see all the list of transactions which are happened in a single day. They can see like this. They'll have all the, let us assume there are 1000 transactions have been completed in a single day. Now they can see and they can analyze all the 1000 transactions. In this example, we took only 6 items, but in real time in any shopping mall, we can find thousands of products are available in a shopping mall. So when we want to apply this type of algorithm into a real-time market or real-time retail market, let us assume the complexity of the algorithm. So where we are having thousands of products, thousands of customers, every transaction will have its uniqueness, and all these factors are going to be considered in order to analyze. So when we want to identify the customer behavioral analysis, these algorithms are going to be applied in real-time applications. Now, what is an advantage of a priori algorithm and what are the disadvantages of a priori algorithm? We'll see. One of the main advantages is we can use a large item set property. That means we can generate large item sets. We can generate item sets using parallelized concept. It is very easy to implement in real-time applications. When it comes to disadvantages, it consumes more memory when it is generating items, because when we are generating more number of item sets, it requires more memory, that is primary memory, and it requires more number of database scans, that is more number of database read operations are going to be applied on the database. Now we can't say these are the advantages, we can say these are the challenges. When we are having a high-end memory or hardware support, we can convert these disadvantages into advantages. Now another algorithm to generate association analysis is sampling. Now what a sampling is going to be done? Here in sampling, when we are having a large database in real-time applications, instead of selecting that entire database at a time, better consider a portion of the table or portion of the data, and that data is going to be applied for analytical activity. That means select the sample database and apply a priori to the sample. Let us take one small example here. Here we are having 1000 transactions. 1, 2, 3 up to 1000. Instead of selecting all the 1000 transactions at a time, apply a sampling algorithm. Divide this 1000 transactions into 5 subparts. Let us assume 1 to 200 transactions in sample 1. Second sample, consider 201 to 400. Like this, fifth sample will have 801 to 1000. What we are doing? We are repeating same algorithm parallelly more than one time. Here we are repeating a priori algorithm for 5 times. That is, sample the database and apply a priori to the each and every sample. Now, how this sample is going to be selected? It is a main aspect here. Can we select randomly, or can we select based on serial number, or can we split the database? So it depends on the sampling approaches. Those approaches we'll see in coming slides. Now here we'll focus on how these large item sets are going to be taken. When we are having a potentially large item sets, here notation is PL. When we are having potentially large item sets, generate one sampling border. That sampling border means separation of the elements. Here we created a sample for every 200 elements. Now here, generalization of a priori applied to all item sets of varying sizes. Here we took only fixed size. It is not mandatory that we have to divide the sample only for a fixed size. We can go for a random, like sample 1 may have some 300 transaction, sample 2 may have some 400 transaction, sample 3 may have some 150 transactions. This is also, there is a possibility of selection or applying sampling. So this is varying sizes of the sampling. And minimal set of item sets which are not in PL, that is, which are not in potentially large item sets, but whose subsets are in PL. That means if any item set which are not in a larger size, all of its subsets definitely will be in a potentially larger, that means repeated items. Now here, this is the way of generating the border items and non-border items. If you look at carefully these two diagrams, same lattice structure have been taken into consideration. If A, B, C, D, if you look at carefully, here A, C and D and CD, which are highlighted in a bold face. And if you look at this potential large items union, the border value minus field, that means which are not up to the mark. Now what is the case which are not up to the mark? If you look at carefully here, if the item set CD is not considered for analysis, the subsets of C and D, that means the subsets of CD are C and D, will be in consideration. That means when we are not, from this point, if you are not considering for analysis, the above level can be used for analytical activity. That means we can't take any subset which is combination of CD again here. That means we can't take BCD, we can't take ACD, we can't take ABCD, but we can take C and D. That is a way of doing. Now if you look at if this level, at this level, if C and D is not considered for analysis, then we can go and we can select the upper level values. When it comes to this reverse approach, when A, B, C and D are considered as large item sets or large sets, then all of its supersets, like supersets of A, AC, AD, supersets of D, CD can also be a larger item set. It is not mandatory that all supersets. There is a possibility of some of its supersets may be in larger scale. So this is the way of selecting a border and restricting the formation of larger item sets. Now this is the algorithm of how a sampling algorithm is going to be applied. So in this sampling algorithm, sample the database. That means here we are dividing the database. Sample the database capital D into DS. That is, in our previous example, 1000 transactions we taken into 5 samples, like DS is one of the sample. Now large item sets in DS using smalls. That means in sample 1 we are having 1 to 200 transactions. Among these 200 transactions we want to create item sets. We want to create large item sets. And all large item sets which are created from these transactions are going to be kept in PL. And look at here. And what we are doing when some of the elements have been neglected, like among these 200 transactions, let us assume we formed 40 item sets. Look at carefully here. 1 to 200 are the transactions. Let us say 200 customers. But here we are not taking into the customers. We are considering the item sets which are repeated by more number of customers. So here the input data is a customer transaction data, but we are not focusing on customer. We are focusing on items. So here the item sets, let us assume here we got some 40 item sets, and we are combining those 40 item sets with some of the border value which have been missed during the analysis, and we are storing all the values in C. Now count C in database using S. So compare with the database S. Here S indicates the sample data set which we have taken, and large item sets which are again the remaining portion of the data are going to be repeated. If ML is equal to 5, then our work is done. That means no items have been left in that analysis. Hence, repeat the process or repeat the application till we complete all samples. Now, what are the advantages of sampling? In sampling algorithm, the advantage is it will reduce the number of database scans to 1 in the best case and 2 in worst case. That is, at a time it will read all the elements, and most probably it can go up to 2 data rate transactions, and it scales betterly. When we compare with the previous example, sampling will give the better results. Now, what is the disadvantage here? Here, potentially large number of candidates in second pass. That means whatever elements which has been left out in the first transaction, it will increase the load in the second pass. And another way of creating item sets is using partitioning. Till now we have seen applying a priori algorithm, sampling algorithm. Now we are going to focus on partitioning algorithm. Now, what is the difference between sampling and partitioning? In sampling, there is a chance of selecting item sets randomly or fixed size. Here, we are dividing the database. A database can be divided horizontal or vertically. It depends on the selection of the data. Like here, what we are doing, divide the database into partitions. Here we form P number of partitions, D1, D2 and so on up to DP. Apply a priori for each partition, the same approach. Apply a priori algorithm for a D1, algorithm for a D2 and repeat the process up to DP. That means same algorithm we are repeating for P number of times. Any large item set must be larger in at least one partition. That means among all these P partitions, at least one item set. Any large item set must be in at least in one even of the partition. If there is no item set was found in any partition, then that is not considered as a large item set. It can be in all data sets or in all partitions or at least one partition, the item set should be repeated. Now look at here, how this is going to be applied in dividing algorithm. So here initial step, we are dividing the database into partitions like D1. These are the database. Here we are partitioning into, this is D1, D2. Like this we can go for up to D to the power of P. Divide the database into partitions. Next we have to repeat the process 1 to P. For every database partition, we have to apply the algorithm. Like first we have to apply algorithm for a D1. So I equal to 1 to P. P is the larger number. Let us say it is P equal to 10. So here we want to repeat the process up to 1 to 10. Now what we are applying? Apply a priori algorithm on DI, that is 1. Apply a priori algorithm on D1. Now what it will apply? On this D1, we are applying algorithm by creating candidate item sets. And next, generate large item sets and apply candidate pruning approach. Generation, creation and pruning. And after this, we have to repeat the process up to 10 times because here we have taken 10 partitions. And after getting the results like item sets which are formed from L1, L2, all are going to be combined here. All item sets which are formed during all these 10 iterations are going to be combined. And finally, we will take the count of large item sets which have been generated. That means same algorithm we are repeating more than one time based on the partitions. So this is an example of partition here. So the total database is having some 5 transactions. We divided 2 transactions into partition 1, that is D1, 2 transactions, remaining 3 transactions into D2. So D1 and D2 are the partitions. So when we partitioned, on this upper portion, we will apply a priori algorithm. And on the second portion also will apply a priori algorithm. Now, the results of this T1 and T2 transactions have been recorded in L1. And the item sets which are created in L2, that is from D2, have been recorded in L2 here. All 2 item sets which have been created. All item sets which are repeated here. Like here bread, jelly, peanut butter are the 1 item sets. Bread, jelly, bread, peanut butter, jelly, peanut butter are the 2 item sets. Bread, jelly, peanut butter are the 3 item sets. So here we are having 1, 2, 3, 1 item sets, 1, 2, 3, 4, 2 item sets, 1, 3 item set. Like this, in this remaining 3 transactions also we formed all 1 item sets. These are the 2 item sets. Bread, milk, these are the 3 item sets. So the support value of 10. Here we can also increase. General support will be taken minimum 30 to 50. If you take a 10, you will have more number of item sets. So here what we have done, we applied a priori algorithm parallelly on 2 partitions of the database, that is D1 and D2. Now we'll see what are the advantages of partitioning algorithm. The major advantages are, it is best suitable for available main memory, that it adapts to the available main memory, and we can implement a priori algorithm in parallel. maximum number of database scans is required is only 2. And what is a disadvantage? It may have many candidates during the second pass or second scan. So these are the advantages and disadvantages of a priori. Now, the enhancement of that a priori algorithm is parallelized a priori algorithm. That means repetition. In partitioning, what we have done? We applied parallelized a priori algorithm on all the partitions of the database. Likewise, we can apply the parallelized a priori algorithm in all possible levels. So, what is happening in parallelized approach? The basic concept of algorithm we are adopting only a priori. We are using a priori algorithm. And what differs technically? What is counted at each site? How data is going to be distributed, or we can take as a challenges. Now, what is happening in data parallelism? We are dividing the data into partitions, and we are using count to distribution algorithm. When we are taking data parallelization, we can use partition the data and we can apply count to distribution algorithm. When we want to do task parallelism, data and candidates are going to be partitioned and we can apply data distribution algorithm. That means we can apply operations either vertically or horizontally. If you are applying horizontally, we can call it as count to distribution algorithm. If you are applying vertically, we will call it as a data distribution algorithm. These are the two flavors of a priori algorithm in parallelism. We will see those two algorithms here. The count to distribution algorithm. Let's have an example here so that we will have a clarity. So in this count to distribution algorithm, there are three partitions have been created. That is, entire database have been divided into three partitions. Like in first partition, in D1, we got two transactions, that is T1 and T2. In second partitioning, the name of the partitioning is D2. Number of transactions are T3 and T4. And in third partitioning, we are having only one transaction. Now, what we are doing in every transaction, or you can say, in these two transactions, we will take the count of individual item. Like in T1 and T2, beer is repeated only 0 times. Bread is repeated 2 times. Jelly is repeated 1 time. Peanut butter is repeated 2 times. Like, we are repeating the same process here. Look at here. Apply the count on each and every item. Like peanut butter is 1, milk is repeated 1, bread is repeated 2 times. And the same operation is repeated 3rd time. Like peanut butter is 0, jelly is 0, and bread is 0. Remaining 2 items are repeated 1 time. Now what we are doing? Here we are taking the count of each and every item together here. That means how many number of times peanut butter is repeated. So if you look at count here, it is repeated 3 times in all the 3 transactions. Now what we have done here? We are divided data in parallel. Data parallelism. Totally 5 transactions. 2 transactions in one partitioning. 2 transactions in second partitioning. Remaining 1 transaction in third partitioning. That is T1 and T2 in D1. T3, T4 in D2. T5 in D3. So parallelly, we are applying a priori algorithm on data. So this is called count to distribution algorithm. Now we will move to the algorithm now. This is the thing here. What is the first step we have done there? We divided data partitioning at each side. Place data partitioning at each side. What we have done? We divided P1, P2 and P3. We have given name as D1, D2 and D3. In parallel at each side do. What we are doing? Look at carefully these 4 lines here. item sets of size 1 in I. That means count all the 1 item sets, that is C1. Broadcast count to all the sites. That means let us assume here bread is repeated one time in first partition. Now distribute this count to remaining 2 partitions, so that the cumulative count is going to be happen to item called bread. So here what we are doing, we are creating item set, we are taking the count of it, and we are communicating that count with remaining all the partitions. Determine the global large item set of size 1. Whichever is having larger scale, that will be taken into consideration. We will move back again to understand the algorithm here. Look at here. Here peanut butter is 2. Here the peanut butter is 2. Butter is 1. Now what we are doing? This peanut butter count is going to be compared with peanut butter in P2. Here the count is 2, it is 1. Again, this is going to be communicated with this one. Here it is 0, it is 2. Now it is larger value. Now the same manner, this will also communicate with 1. If you compare one, this is larger one. But if you globally, this is the larger value. So in every partitioning, we are forming 1 item sets or 2 item sets. And the count is globally we are communicating with by all partitions using some partitioning approach. Now take it here. This is the activity we are doing in step number 2 to step number 6. Count of each and every item set, broadcast the count to all the sites, determine the global item set. And we have to repeat what we are doing, we are repeat the process, that is I plus 1. And after that, what we are doing, we are applying a priori algorithm on each and every partitioning. Apply a priori algorithm, found the best item set, count, broadcast the count to all the sites, determine the global large item set of size L1 until there are no more large item sets are found. So here, when we are dividing data parallelly and we are applying a priori algorithm in parallel, we can call it as count distribution algorithm. Next one is data distribution algorithm. Here also we will see algorithm first, later we can understood algorithm properly. Now here, if you look at carefully, here also we formed 3 partitions. Partition 1, 2 and 3. Likewise in CDA, here also we are having 2 transactions T1 and T2. Here we are having T3 and T4. Here we are having T5. But if you look at carefully, here items have been distributed. That means, even though we are having 5 transactions, in all 5 transactions there are only 5 unique items. The items are beer, bread, jelly, milk and peanut butter. These are the 5 items. Now what we have done, instead of using all the 5 items in all the transactions, here items have been distributed. In first 2 transactions we will take beer and bread. In second 2 transactions we will considering only jelly and milk. In last transaction we are focusing on peanut butter and communicate the database partitioning. That is the meaning here. In previous example, that is CDA, all items are available in every partitioning and we repeated for 3 times. Here the items have been distributed even though after doing the partitioning. This is called task distribution data, called data distribution algorithm. Let's have a look on this algorithm here. Place data partitioning at each side, same thing. We have done 3 partitionings, P1, P2, P3. The name of the data partitioning is D1, D2 and D3. Now what we have done, determine the local candidates of size 1 to count 1. Determine the local candidates of size 1 to count 1. broadcast local transactions to the other sites. Like in partitioning one, we taken the bread. The bread count, let us assume bread count is 0. The count has been communicated to all the remaining two partitions, that is P2 and P3. Count the local candidates of size 1 on all the sites. That means take the count of all one item sets in all the three partitions. Determine the large item sets of size. Now, so this, if you look at the steps here from step number 2 to step number 9, we are applying candidate selection, candidate generation based on the partitioning by splitting the data. And after completion of this, we are repeating a priori algorithm. Same a priori algorithm here. Candidate generation, determine the local candidates, take the count of each and every item set, broadcast it, repeat the process until there are no more larger item sets. When we are dividing the data parallelism, we can go CDA. When we want to do the task parallelly, we can go for DDA. Data distribution algorithm. Now these are the comparing all existing a priori algorithms. Here, based on the type of the data, source of the data, transaction strategy optimization, we can use any one of the approach. If we look at the all existing a priori algorithms are here we are having a priori, sampling, partitioning, CDA and DDA. So in a priori, the required number of database scan operations are m plus 1, where m is the number of elements. When we are using sampling, maximum we require 2 database scans. When we are using partitioning, maximum we can take 2 database scan operations. When it is CDA and DDA, it is almost equivalent a priori because we are repeating a priori algorithm more number of times. When we want to reduce main memory related operations, we can prefer sampling and partitioning. When it comes to data structure which is used in implementing these algorithms, hash tree has been used in a priori algorithm. Sampling was not specified because it is not a architecture related, it is only a selection of the data. Partitioning is done based on the hash table and remaining CDA, DDA are hash tree. That is, a priori algorithm, CDA, DDA are based on hash tree approach. Parallelism. Here in a priori there is no parallelism in sampling and partitioning. Only CDA we are applying data parallelism, DDA we are applying task parallelism. Now this is a way of creating a hash tree. That is all possible elements of hash tree. Now how can we increment the process of association rules? That means when we are using more number of items are there in a transaction, how can we use and why can we repeat the process in large scale? Now, in order to measure the quality of transactions, here the measures or metrics which are used are support, confidence, interest, conviction and chi-square test. These are the measuring qualities which are going to be applied in association analysis. So till now we have seen the concepts of a priori algorithm, various a priori algorithm related concepts like creation of item sets, generation of item sets, pruning of item sets, and we have seen implementation of a priori algorithm at various levels, either by doing sampling or by applying partitioning. Based on the parallelism concept, if you are doing data parallelism, we can use CDA algorithm. If you are using task parallelism, we can use DDA algorithm. So with this, we can complete our association analysis. Thank you.